Welcome to Brain Vision.
Okay, so this problem asks us to determine the internal forces at point J when alpha equals 90. So alpha equals 90 means that this force right here is acting completely down. And we also know that there's going to be reaction forces in the y and x direction at point B. There's going to be one reaction force at point A due to the string. And based on the dimensions given, we can also set up a 5, 12, 13 force triangle right here. Based on just this diagram here, we can just take the moments about point A, and we can say that that moment about point A is 0. And because of that, By must be 0. Since there is a moment about A, Y acting kind of in the same direction, so that means that's 0. And then to find A, we say that the net force in Y equals A times 12 over 13 minus the 780 at the bottom, which equals 0, the 12 over 13 coming from the force triangle. So A equals 845 newtons. And then we can go in the x direction to find the x in a similar fashion. So the x direction equals 845 times 5 over 13 plus bx, which equals 0. Oops. Equals 0. And so bx equals minus 325 newtons, or 325 newtons if we just want the magnitude. Okay, now we're going to use the fluid body diagram. We know that we have a 325 Newton force here, By, Bx, which means at this angle, you can see that the 513, 512, 15 triangle has been put in again here. So this vertical force along the bar is 125 newtons, and the force perpendicular to the bar is 300. And so what we're solving for is these values down here. So again, we run through the equilibrium. We say that the net force parallel to the bar equals 125 minus F, which equals 0. So F equals 125 newtons. And we can use the force triangle to say that it is acting at a 67.4 degree angle. And then the net force in the parallel direction equals V minus 300, which equals 0. So V equals 300. Again, using the force triangle angles, it is 22.6 degrees. And then finally, to find the moment, going back up here, we have found V, we have found F. We need to find this moment here. If we take the moment about this point, the only force that will cause a moment is the 325 Newton force, which is acting exactly 480 millimeters away. So that moment is 0 equals 325 times 0. Point minus m equals 0. So m equals 156 Newton meters, and we know that that is in the clockwise direction.